Oop. All right, hi guys. Thank you for coming to Public Sector DC Summit. My name is Sebastian. I'll be your room host for the day. Some housekeeping items. If you can, the exit is located right behind you. The bathroom is down the hallway. If you can, please silence your cell phones, and also if you can download the Public Sector app, and by the end of this session, if you can submit your feedback, that'd be appreciated. And then with that, I'm presenting on modernizing your application development environment with a move to the cloud. Please welcome Rick Wiggins.
Hey everybody. Actually, I'm going to welcome on stage my colleagues, please. I'm Rick Wiggins with AWS Professional Services in the public sector, nonprofit organization. This is my good friend and colleague, Cole Hubbard, who is here and is going to be talking about how we helped modernize this application. And it's my great pleasure to introduce David Shive, the CIO of the General Services Administration, who's going to talk a little bit about their journey into the cloud and how they've modernized some of their applications. Thanks, guys. I appreciate you joining me. Let's set up with a really quick agenda here. We had a very large federal customer that we went into with the idea that they needed to essentially start shutting down data centers. If that sounds kind of familiar to some of you out there in the audience, see some nodding heads. Hopefully the lessons we've learned in the process here will apply to you, which would be great. This is our agenda today, all the way from establishing goals, getting through discovery, doing the refactor itself, the results that we have, and eventually introducing the new normal to this organization. So here's the big picture in a really quick summary so you can kind of understand where we were trying to go with this organization. They had 2 locations in co-location that they wanted to shut down completely. They wanted to migrate these applications into the cloud. They wanted to go cloud native if at all possible. They wanted to use native tools if at all possible. Their goal was to move all of these applications within 2 years. Our initial discovery was something like 800 applications that we needed to fully discover, evaluate, and figure out a strategy for actually moving these into the cloud. And we needed to establish a model for migration. These applications would typically use different techniques. Some of them were going to move over and stay using the exact same platforms. Some needed to be migrated over and needed to change database engines. If anyone out there is affected by the Microsoft SQL 2008 R2 deprecation, we have that sort of challenge at this customer as well. So we needed to be versed in all of the techniques across all these applications. We needed to be prepared with patterns for migrations so that we were allowing our staff to accelerate the migration of these applications using lessons learned from an initial set. So we did a readiness assessment. Each application, we evaluated a small subset of applications nominated by the customer that we could get started. We typically wanted applications that were able to be patterned so that we could move one, learn lessons, and then move several that look kind of like it. Originally, there were 4 applications that were chosen that fit individual migration patterns. And today, we're going to deep dive into a single one of those applications, which was an implementation of MediaWiki, an internal wiki for this large government organization. I see some nodding heads out there. At least seen MediaWiki before. So I will talk about kind of what we walked into and what we had. And Nicole is going to talk about how we actually got it into the cloud. So first we started off with discovery. This was our current state diagram when we went through discovery. I'm going to get into a little bit about what we found out when we got in here. This was a very typical 2-tier web application with an application and a database, and it had a tool server running in the background, which was essentially running cron jobs and things like that on the MediaWiki itself. So there were 2 servers per environment, a single database and a single application per side. So that was they had a production side. They had a development side so they could do a little bit of testing before actually moving to production. It was not accessible from the internet. So we had to figure out a way to get networking, routing, and pathing done for this application while maintaining internal security for it. It used an internal package repository, so we needed to be able to facilitate updates from that internal repo instead of something forward and out on the internet. And it was highly frequented. We had high utilization for this application by internal users in the company. It was their single source of information for company procedures, for operations, for planning, and it was crucial that this didn't go down while we were actually migrating this. However, as crucial as this application was, we actually found out they had an RTO, RPO of 24 hours that was acceptable to them, and that was one of the goals. We wanted to help make this better for them after their move to the cloud. After we finished discovery and we had all of this information about what this application was and what this environment was, we actually presented it back to the customer, and they let us know that this was the most complete documentation they have ever had for this application, just in discovery to figure out what it looked like previous to the move. So they were even appreciative of this discovery phase, but starting off knowing what you have is an incredibly crucial step if you're going to be successful in your cloud journey. We laid out some target state goals for them. Like I said, we wanted to use AWS native services whenever possible. We wanted to implement source control for them. We wanted to give them native monitoring. And we wanted to modernize deployment of this application. We wanted to remove some of the operational pain. We met and we made friends with the application owner, who was a very, very nice guy in a pretty stressful job. And we asked, what are some of the operational pain points that you see right now? He wanted to improve resiliency of his application. He wanted a faster release time. He had lots of ideas. He had lots of functionality he wanted to implement, but the current implementation of the application just didn't support the iteration that he wanted to put into the application. We wanted to make that better for him. And he didn't want to have any more midnight maintenances where he had to stay up till 2 in the morning, because that's when he was allowed to mess with the server and actually push code functionality and features out into the environment. And he wanted to automate his backups. This was something that it was very crucial, and we wanted to make sure that backups were auditable as well as resilient as well. He wanted accountability for cost. He had upper management and leadership asking, how much is the run rate? What is the expense? How do we do back billing to organizations who are consuming our wiki inside there? So we needed accountability for all of that. He wanted to scale based on time of day, which was very forward-looking. This is an advantage you get when you go to the cloud. If you understand when your users are going to frequent the platform, you can make sure that the application is ready to receive that use case on a schedule or based on who is actually looking at this. So we wanted to be able to lower cost by essentially turning it down to the bare minimum in the middle of the night when no one is previewing the wiki. And he really wanted to get into iterative development and security while in the deployment platform. We call that DevSecOps, where security is right there in the middle of your DevOps process. He was very forward-thinking. He was very interested in that, so we wanted to integrate security in the actual deployment of the application. We wanted to create a multi-environment deployment for him so that he would have sandbox, dev, test, prod. We wanted to be able to commit a single piece of code into a code repository and have it graduate with governance, with checkpoints through the pipeline and make it to the iterative environments based on their existing procedures and processes. We had to have governance in place. This was a large federal organization. Governance was not an option, and we wanted auditability at any time. And we wanted guardrails. We wanted best practice security guardrails coming from AWS. We wanted to inherit some of the guardrails that we needed via FedRAMP. We wanted to place additional guardrails in there for security and compliance and identity and things like that, which we can take advantage of in the cloud. And now I'm going to hand it over to Cole, who is going to talk about, now that we know a lot about this media application, how do we make a determination about how we're going to get it into the cloud? Cole.
All right, so this leads us into the first crucial decision that this customer had to make, and that was choosing the R. When we talk about R's, we think about methods for moving an application into the cloud. There's about 8 R's that I know of. I'm sure there's many more and will be many more in the future. That being said, we were looking at 3. There's the rehost, which is similar to moving a virtual machine to a new host. You just take an image of whatever it is you currently have. You plop that into an EC2 instance or somewhere in the cloud, and that's what you get. The issue with that one is it's a great use case if you're trying to go fast. If you want something moved within 24, 48 hours, within the span of a week, go ahead and rehost it. The disadvantage is it's not cloud native. What you put in is exactly what you get in the cloud. You can re-platform the application. So re-platforming is changing the application's operating system and then just reinstalling. Think along the lines of, I have a brand new bare metal server that I need to install this application on. So let's get a new OS loaded on there. Let's reinstall the application, reconfigure everything for this new server. It's a good use case if you have licensing concerns, end-of-life software, end-of-life hardware. If, like you mentioned before, the SQL 2008 thing that's going on, if you need to upgrade things, that's when you would re-platform. The drawback of that is sometimes you don't get that additional optimization that you really could get if you were going to move the application to the cloud. The next way to move an application in that we were considering is a refactor. And this is when we tear down the application down to the source code. We start making changes to the configuration of the application, the way that we think about configuring that application on a server. We really dig in deep and go from the bottom up as if it were a brand new build. We throw everything away from the initial running state and use that as a guideline. We know what we want to get out of it, and we start brand new. This provides a cloud-native architecture. So we're able to design the application for new cloud technologies like serverless compute, the relational database service, database as a service platform. We're able to take into account auto-scaling and how's the application going to react to auto-scaling. The drawback is that it requires time, it requires flexibility, and there's a little bit of a learning curve involved. This customer ultimately chose to refactor the application. So we started on the process. We decided to go through several iterations, and within these iterations, there were multiple releases. So we're going to talk about 4 main iterations today. During the first iteration, we took a look at each part of the application. What is it made of? We know we've got application instances, we know we've got a database, we know we're going to need file storage, and these are all just very general concepts. But then we can map those into AWS services. So we know that we wanted to map everything out, and in order to do that and really be cloud native, we decided early on to leverage all of our infrastructure as code. So the first thing we did before we started any work is create a repository that we can store all of our work into. This provided, right off the bat, change control, change management. If I go in and make an update to the application, my counterpart at this organization could see that and see exactly what I changed. And if he made an update, I could see exactly which lines of which piece of code that he changed. So it was really helpful because I was working remote with this customer. He was based out of the Washington area, and I'm based out of Dallas. So we didn't see each other in the office every day. Yet we were still able to have a great communication with each other and understand what each other were working on. The second step of this was mapping all of the legacy solutions to AWS services. So we decided that this application it's MediaWiki. It's going to need web servers. Let's run those on EC2 instances. It has a database. What type of database was it? I believe they were using MySQL. So we mapped that to RDS and decided that, yes, we want high availability. Let's go all in on RDS and see how it performs. We mapped all of their file storage. Since we had to think about auto-scaling, where instances can pop up and shut down at any time, we had to keep the file storage separate. So we decided that we would use EFS for that job. And they had a few cron jobs running as well, and we decided to try to port those over to Lambda. The end result being a fully portable deployment piece and piece of library of code that they could deploy out anywhere. Everything is described by code. You hit the go button and watch it deploy. Now, I do want to note, while we were making these decisions, we weren't sure if they were going to work. We weren't sure if the application was going to respond well to auto-scaling. We weren't sure if the speed of the Elastic file system was going to be good enough to serve out as much data as they were trying to serve. We weren't even sure if we could get the cron jobs to run in Lambda. So we approached all of these decisions as what we like to call a two-way door. If we try something and it's not working, we can back out and try something else. This is essentially net new at this point, even though we're working with a pre-existing application. So it was a good place to experiment and really learn those lessons that we tried to get learned during the migration process. So this is kind of a visual representation of how we mapped everything out. At the end, once we had mapped out all those services, we decided to wrap everything in CloudFormation, which is a deployment service that takes YAML or JSON files, and those YAML or JSON files describe the desired state of an infrastructure in AWS. So at this point, we had the mapping and we wrote the code, one resource at a time. And one of the ways that we did this, they were coming into AWS net new. They had never really touched CloudFormation before, and one of the ways that we learned CloudFormation together was going through the console, and each time, try to launch whatever you need. Launch a web server in the console, and each time you click the mouse, write that down. What did you click on? What did you do? And by the end of it, you have a good guide as to what you built. And then you look at the CloudFormation documentation, and you can generally map that guide one-to-one back to the syntax that you need to write the code. So by the end of this, we had our counterpart at this organization was fully versed in CloudFormation. He had been able to write this entire template himself. So that was great. Iteration 2. Now we have the infrastructure online. That's great. We've got an empty server, an empty database, an empty file system. Let's talk about the application code itself. And the way that we approached this was asking the question, if I gave you a brand new server that has just been racked, it's shiny, it's got the little plastic thing that everyone loves to pull off on it, how would you get the application on that server and running in a production-ready state? And that's just a list of steps. We just think about automation as a list of do this, then do this, then do this, until everything's done. So that's how we approached it. First, we looked at the installation of security software and operating system level customizations that they already had in place. Then we looked, once the operating system was ready to go, we looked at the deployment of application files. We decided to use the code deploy service, which interfaces with the code repository that we had created during the first iteration. And that's kind of a rundown of the type of code that we were writing. For those of you that can't see it in the back, we're basically mapping locations in our repository to locations where we want those files dropped onto the server. So it's a giant file that describes drag and drop operations, essentially. We additionally wrote a few scripts that needed to be run during the installation. Things like installing packages, installing services, your normal system administration stuff. And we rolled that into CloudFormation and then into code deploy. And now we're building and configuring servers automatically. So the next time we get updates that need to be made, a release, a package installation that needs to happen, they update their code, they press go, and they twiddle their thumbs for about 20 minutes until it finishes. In addition, we're doing validation checks for each of these steps. So we run the script to make sure that a package was installed, and then we make sure that it was installed. And if at any point any of these automation processes fails for any reason, it can automatically roll back. And with that rollback, they gain the flexibility of being able to make changes in the middle of the day. We're no longer worried whether an automation step will fail, whether a deployment will fail. Their application keeps running. At the end of this, and it took several iterations of our deployment code to get this working, we were greeted with the MediaWiki login page. That was a very good day. Now, we had one copy of this running, and I like to say that everyone has a development environment. Some people are lucky enough to have a separate production environment. So we needed a way to get this code from development through their test environment all the way into production and have a governed process on how to do this. So once we have this deployed in a sandbox account, we built a pipeline. And this pipeline allows us to use that application file, the CloudFormation template that we had written during the last 2 phases, throw that through the pipeline and graduate it to multiple accounts with manual approval steps, security checks, all of those things happening in line during the deployment process. So our pipeline looks similar to this, and what it does is it reads off of that original code commit repository. Our new code goes into the pipeline. CloudFormation is processed into the sandbox account. The resources are deployed. Code deploy automatically runs and deploys and configures the servers with the application and puts all the data in place. We get that nice fancy MediaWiki login page. And then there's a manual approval step. And we have scoped that manual approval step to where only certain people can push that button. We repeat this process for every environment that they have. So this can scale up to, they're using 4 environments, we can use 2, we can use 300. The sky is the limit with this. And we can put all sorts of checks and balances into this process. A pipeline is, again, just a series of steps. Iteration 4, now we have this application successfully graduating different releases from a sandbox environment through development, up through test, to production. We decided to work on performance and monitoring. We have a working product now. How do we get useful data out of that working product so that we can improve it? So we asked the application owner, what are the critical metrics for you? What matters to you? What information do you want to see? We identified all of those metrics. And in our next release, in line with the code that we use to deploy the application itself, we programmatically create a dashboard for him to look at. And this dashboard provides interesting things like the CPU utilization of the average CPU utilization of all of his instances that are running, the network throughput of the database, how many queries are coming through, how many instances do I have in service, how many active connections do I have right now, how many requests have I done in the last 24 hours. Additionally, he wanted to see data through logs. So we wanted to be able to provide real-time logging. All of his instances, it doesn't matter if he has 2 running at a time or 100 running at a time. We used CloudWatch and automation to chew up the Apache logs in those instances, export them into this dashboard in real time. So when I go visit his MediaWiki site in a browser, I can see my log entry come through on the dashboard. This will help alert him to any problems that the application is having. Additionally, all these dashboards allow the customer to zoom in and see what happened this morning at 5:30 a.m. when I was just rolling out of bed. Why did my server decide to go down last night at 2 in the morning? He'll be able to zoom in and look at all those metrics. And at the end of the day, he really just has to worry about, hey, why did this happen? He's not worrying about, did my site go down? Because it's all instantiated through code. So everything heals itself. And there's a larger look at what that dashboard looks like. Moving on, we have outcomes. And I'll hand it back over to Rick for the outcomes of this whole process.
Thanks, Cole. I appreciate that. Okay, so that was it. So that was the 4 iterations that we went through to take an application that was running in a data center environment with traditional rack and stack and wires and hard, hardware sitting over there all the way into a cloud-native solution. And it's important to note that all of the lessons we learned when we moved over MediaWiki immediately applied to several other applications that are in those 800 that we're still planning on migration. This migration is still in flight. We have a lot more applications and a lot more work to do, but this was one of our first successes. It was actually touted internally. They put up posters in the hallway about, guess what's running on AWS now, and because they're public and their consumers had no idea that we had made this transformation and transition for them. They just saw this performance increase, and they didn't know why, and it was pretty cool. So let's talk about the outcomes. What actually we got out of this, and I wanted to remind you what the target state goals were. And we did circle back around at the end of this product. We needed to make sure that we met all of the goals that we defined early in the process. So we did end up using AWS native services for all of the deployment steps, for all of the storage of the code, for all of the graduation of the code through, as well as security inline in the pipeline. We did that with a series of services here, code commit, CloudWatch, code deploy, to get those native services in there and actually put them in charge of the infrastructure as well as the deployment of the code. We removed operational pain that our owner came to us very early in the process and said, hey, this is not very fun to have to do these midnight releases and things like that. We increased his resiliency with auto scaling. He has a faster release time now because anything he pushes into that central code repository can easily be graduated as long as he can meet his change management and get his sign off inside of the governance there through code pipeline. He has no longer to do midnight maintenances. We actually did a maintenance on this 2 p.m. in the afternoon. He had a feature that was ready to go. That's fine. We can graduate it into sandbox, dev, test, have you guys use user acceptance testing. We can push that to prod. There's not even a restart of the services on the server. And we automated backups for him. EFS already has snapshot backups available. AWS Backup is now an awesome product that's available too. So we was able to gather that functionality as well with very low lift from his side. He was very excited about that. We established accountability through CloudWatch and giving him access to the logging that we put into place, as well as additional visibility into the billing and his actual utilization per minute of the service, which is the kind of granularity he needed. As well as Lambda to automate all of his cron and scheduled tasks that originally he was maintaining an independent server to do, and all of the updates and things that came with the lift for that has now all been automated into a serverless environment. And we gave him the gift of DevSecOps. And I say we gave him the gift, but actually in reality, he gave us the gift of DevSecOps. He was a very interested owner of an application who was ready and begging us to advance his application and things like that. And he was a crucial stakeholder in this entire process. We did pair programming with him when we were doing CloudFormation. He was writing those Lambda functions. He was ready to take on some of that functionality so that he grew his cloud skill as we helped him transform his application. And he came out of the end of this as a champion for AWS Web Services and an internal source of knowledge for the organization, which was fantastic. He's now been put in charge of other applications that are going to be transforming and doing this migration because he's already done it, he's already seen it, and he's already getting the benefit from it. We've established governance and guardrails with AWS Config, with Guard Duty, with the built-in security that is placed in the pipeline through an open source product called CFN-NAG, which if you haven't seen it, is fantastic, that you can write your own custom rules for and actually catch things in CloudFormation before they even make it into your environment. It's preventative control instead of detective, which is fantastic. And we were able now to enter into the age of the new normal. And this is where we are today. And I'll remind you of our old state diagram. This is what we looked like when we arrived on site with this customer. And this is what it looks like today. It's a very busy slide, but Cole has kind of talked through it already, and I'll hit on some of these parts. This part at the very top here is the MediaWiki deployment pipeline. Code commit, where the code is stored. Code build to be able to onboard that code into running instances, CloudFormation and code deploy to push out the infrastructure and the application into the working environment, all that wrapped inside of code pipeline, deploying across those intermediary environments and graduating all the way up to production. What a single one of these environments looks like this is inside of a private VPC, remember, because we had no external internet access. We have lockdown via an application load balancer, a set of 2 instances that run at all times in separate availability zones. Availability zones are a concept inside of AWS where these servers are running essentially on independent power, independent cooling, independent network connectivity. So we achieve that resiliency that he was after. The file storage has been moved down a level into Elastic File System, a file system that is shared across those availability zones and is available to as many instances as we'd like to put in front of it via file share. The AWS Lambda for data ingest and the cron jobs that he was previously running on an existing piece of equipment have now been graduated into primarily serverless applications. And then his RDS database is here, which he doesn't have to manage himself. This is a managed database product. He was not in the business of running a SQL server and things like that. It was overhead for his team that he was not specialized in. We're able to extrapolate that work from him, and he doesn't have to work with that anymore, which is fantastic. This transformation took us about 6 weeks, from the infrastructure running in production to being fully instantiated in code. And we learned so much that we're hoping this can accelerate further applications, and the next application will take nowhere near 6 weeks. About 80% of this code is recyclable for applications that fit a similar pattern. Each time we do this, we're gonna get faster. Each time we do this, we're gonna build an additional skill set, an additional library, and additional functions that can be reused across this organization. So we're hoping to accelerate them quickly into the cloud after this. So this is kind of a look at the pipeline and everything. This is the new normal. When our stakeholder walks into the office in the morning and he wants to make a change to his application, when he's ready to deploy new functionality to his wiki, here's what he does. He makes a commitment, or he makes a commit to the code commit repository here to fire off the pipeline. The very first step we do is we have validation steps for, was this a legal commit? Are you allowed to do this? Things like that. And we run it through CFN-NAG with code build. CFN-NAG is going to digest that CloudFormation. It's going to look for best practices. Are you deploying an S3 bucket that has public read on it? Did you mean to do that? Are you deploying a security group that's open to the world? Did you mean to do that? CFN-NAG can be set up to fail a pipeline if something comes through the pipeline that you have declared is illegal. For example, our pipeline will fail if you place a security group into a CloudFormation template that is open to the world. That's not allowed in our environment. So CFN-NAG actually prevents the deployment of code that could be dangerous to your environment. Great product, go check it out, Stelligent. Excellent at this. They're some of the best at CloudFormation. After that, we land at a confirmation step. Our stakeholder can commit code all if he wants, but we also have oversight and governance to make sure that what he has committed is ready to be pushed out. There's a code review, there's change management, and then we can push it out into the stage here with a manual approval. You can see down here at the bottom. It's a one-click box. We do it through a ServiceNow ticket, through change management, so that everything is auditable, governed. You can tell who did it, why, and when. And then we make a graduation into the test environment, the deployment of the template, the database template, which is separate. Then we push the application to the awaiting servers. And then we have another manual approval if you want to graduate it from test to prod, for example. Then we will sit and wait again for a manual approval after the user acceptance testing has been done there. So this is kind of what this looks like here. All right. That is our new normal. This is how MediaWiki looks today. This is kind of the deployment pipeline that we're able to put in place for them. And here's the graduation to production, for example. It is a fully documented solution. We knew what it was, and we know what it is today. So we're able to push this documentation along with it. The documentation actually lives in Markdown right next to the code repository, .md files. So that you can, when you make a change to the code, you can actually actively document it inside there. This allows them the iterative development environments that they've been pursuing. This is something they wanted to get out of the AWS implementation. The operational pain is gone. They can make deployments with very little risk and very simple rollback with governance in place. Their midnight maintenances are gone. Their hardware lead times are gone. When he used to want to make a sandbox test of a brand new thing, he'd have to wait 6 weeks in a procurement process to wait to buy a server, and then he'd have to wait for somebody on the other end to rack that server. Then he'd have to wait for network connectivity to come along and hook up the things. Then we'd have to wait for a plug to be delivered, and all of that is gone. He can deploy a sandbox environment, do some experimentation, fail fast or succeed quickly, and move on to the next thing with very minimal overhead now. His time to release was reduced now to 20 minutes. When he has an idea and has written some code, we can get it into production in 20 minutes. Most of that is sitting and checking to make sure that things that he's submitting are gonna fly through the security and governance and then waiting on change management. It is fully logged and tracked. Every single one of these steps in AWS is an API call. So every single one of these steps ends up in CloudTrail fully auditable. If you want to know who, what, when, why, where, all that data is contained within here, all the way from the commit to the graduation to the production environment and the deployment of the code. This is incredibly great when an auditor comes along and says, tell us more about this specific commit to the database, and you can track it all the way down to where it made it on the server. It's fantastic. This includes application access from users. This includes administrative access from engineers working on the environment, and includes individual code changes all the way up to that. So this is the new normal. This is our story about a single application running into the cloud, and it is my honor again to produce my brand new friend, David Shive, at the General Services Administration, who's going to share a little bit more about his journey and his organization into the cloud. David, please take it away. Please, applause for David.
All right.
Thank you for joining us. Thank you.
Thank you. Thanks, Rick. Thanks, Cole. And thanks, everybody, for coming out today to participate in this session. I love telling the GSA story. I'm going to elevate the conversation up about 100 layers. Rick and Cole talked about an individual application. I'll tell the GSA story from kind of the top down, and maybe we can meet in the middle a little bit. As I'm going through this, I've about 14 and a half minutes left. I'm going to leave a little time at the end for some questions. So as I kind of blast through this, be thinking about a couple of questions you might have about the GSA story or about your story, and how maybe the GSA story might inform that a little bit. So where did we start? We actually started our transformation play in 2011. So we've been doing this for a while. And GSA is a pretty big enterprise. We have major business functions, 35 major business functions. So we act like a widely diversified corporation in that regard. IT looks like that as well. We recognized that to maximize the value of investment dollars, taxpayer investment dollars, into what we were doing, that we needed to do more with less, and recognized that a pivot to the cloud might be one of those enablers for allowing us to do so. We started simple. We started with what we thought could be some easy wins, moving mail and collaboration out to the cloud. We consolidated 13 different or 14 different mail systems into one, and then pivoted that out to the cloud. Collaboration systems were kind of the same. And did that while working closely with our business, but did it pretty much on our own. The idea there was to win the trust and faith of our businesses, who were pretty nervous about moving out to the cloud. And once we did that and we were successful, and we also partnered with somebody there. Transformation done 100% internally, organically internally, is profoundly hard. If you think transformation is important enough to do, then you should procure resources, organically grow them within, buy them, buy an integrator or something like that to help you do that. If you care about your business, that's an important part of the play. The next thing we did is we took a look at our application portfolio. They were talking about one application. We had about 1,800 applications running. We actually had more than that, but 1,800 that we were going to focus on, and said we're going to do a transformation play, which looked like rationalizing applications down to a series of best practices, and then taking those best practice rationalized applications out to the cloud, so replatforming out to the cloud. Any good transformation play that doesn't have rationalization as a part of it, either rationalization of the business re-engineering of the actual business process, you're leaving kind of money on the table by doing that. We did a 9-to-1 rationalization play, 1,800 applications down to about 200. Yes, there was that much duplication in the GSA enterprise. Same application doing the same thing, but in siloed business units over and over and over again. Centralized on some best practice, reduced the duplication, and then found a suitable cloud environment to move these applications out. And made sure we picked a cloud environment that was sound, stable, secure, and also had a rapid application development environment baked into that so that we could easily configure and tailor business process into codified business process, like automated workflow and document imaging and things like that. Saw some really, really good outcomes there. Our customers found that turning their business process and their business logic into code didn't have to be a multi-million-dollar a year, multi-year thing. they found that they could express their business interests and their business needs, and that the IT team could instead turn that capability out in minutes and hours and days rather than weeks, months, and years. It also allowed us to shorten our investment profile and pivot from doing 5-year, $50 million engagements and then hoping at the end of the 5 years that maybe you met the business requirement, sometimes successfully, sometimes not. It allowed us to shorten those delivery timelines into small, more manageable chunks so that the investment risk was massively reduced. When we did that, our customers started to say, okay, now we've doubled down on you, now we want to triple down on you. But I had a problem. I had a legacy IT workforce that was used to doing things in a particular way, and I found a bunch of high performers to help us with this pivot, but now my customers were coming at me saying, I want you to do this again and again and again. And so I had to transform my workforce. And so we spent a lot of time and effort and energy into training our workforce, buying expertise and inserting it into the organization, doing term appointments to get people in for a small amount of time to help us work and transform, and allowing a hybrid environment of new talent and existing talent doing things in new ways to positively affect the technology that we're using in support of the business. It's a model that really worked. It's amazing. We as techies have been at the tip of the spear, the leading edge of transformation for decades. And it's amazing when you express and expose new ways of doing things to old-time techies, how readily they take that up and take that on as their own, because in many cases they've been doing that for years and years and years, sometimes decades of their career. So we also took a look at what the implications were on the acquisition side. Buying cloud now is very different than buying cloud when we first started our journey in 2011. And so we found that the DevSecOps model that Rick was talking about was critically important to delivering. And frankly, it was actually very similar to how we were delivering back in the 80s when a lot of IT people started working. There used to not be a division between IT and business. It was just techies and business people all trying to deliver capability so the business could become more rapid, become more iterative, and operate at the speed of 21st century technology. We found that when we express that to our legacy techies and our legacy technologists, they remembered that and they recognized that. And so blurring the line between business and technology in a DevSecOps model made a lot of sense. But that also included inserting security into the process and increasingly inserting acquisition. So we stepped away from the notion of having IT people that would do acquisition and do it poorly, or having security people who would secure things really well by saying, well, just turn it off, and then it's really, really secure. Instead, having security baked in from the ideation phase, having acquisition baked in from the ideation phase so that we could put the right acquisition framework around that, having the business baked in at every step of the way so that as business mission needs changed and pivoted, IT was changing and pivoting right along with it. So then the idea of us delivering a 5-year, $50 million thing and being wrong at the end of that 5 years, it makes it impossible to do that. And you know what? Our business actually became really happy about that too. I'll give you some numbers. So when we started our transformation play, we had a budget, typical federal government budget. Now we are delivering IT that's more closely aligned with the business. We've saved 17.8% of our budget, 17.8%, so over $100 million. And our that's $100 million recurring year over year. And our employee satisfaction with the use of technology is at 91%. We're 89.7% last year. It's 91%. Our net promoter scores are through the roof, envy of Silicon Valley kind of numbers. So we're saving $100 million a year, and satisfaction is through the roof. And why is that? It's because we're delivering business capability at the speed of 21st century business. We're not wasting money. I loved what these gentlemen said about reusing 80% of the code. We share everything. The best taxpayer investment dollar spent is one where you can make an investment in a thing and then repeat that investment and repeat the value of that investment by sharing and reusing it again and again and again. So that's one of the key outcomes that we're doing. And all of that thinking and information is baking into everything we do, including new acquisition engagements like our Comet engagement that's out there, including how we interact with our acquisition community, including how we iterate and think and work with our security teams and our business teams. So that's the very high level kind of where GSA is. We just passed 50% cloud utilization, so we're about 7 standard deviations ahead of the federal average, and our people love our stuff. And more importantly, they love how quickly we can respond to the ever-changing business needs, even of government. So I'm hoping that's kind of elicited some questions. I love the practical view from the practitioners, and this is kind of the high-level executive view. I assume most of you are public servants in one way or the other, either directly or indirectly. Hit me up with some questions on either the GSA experience or your experience or where those two might match up. And it's a small enough room. I mean, I think there was supposed to be a mic around, but you can probably just holler out your questions if you want.
How many IT systems has GSA migrated to the cloud?
So numbers, it's in hundreds and hundreds now. We started out in typical rapid application development environments. That was an easy lever to get out to the cloud. Now we're doing actually native development. And remember, we're the procurement arm of the federal government. We buy before we build, and we build as kind of a last resort, but we still find ourselves building considerable capability in all of our business domains, whether it's fleet management, building management, design and construction, acquisition. I mean, really, really broad domains. So hundreds and hundreds of applications. Sure. Oh, and to that end, we find that bad IT done internally, exported out to the cloud, is still bad IT. So you still have to do things like watch for application rationalization, watch for business creep and duplication of the business portfolio and stuff like that. It's just, you got to do it in the cloud. Go ahead. Yeah, so Colleen asked the question, have we found other agencies that followed suit or asking advice? Yeah, so as a professional courtesy, we talk with other agencies and we expose everything we do. We expose our playbooks. Go to tech.gsa.gov if you want to see our playbooks for all of this. Anybody can go to that. And we share not just our playbooks, but our configuration management scripts and our code, and everything is shared out there. Yeah, they came to us for a long time. The ask was actually so great that we stood up a digital consultancy to manage that load. Most of you have probably heard of 18F or the Presidential Innovation Fellows or Technology Transformation Service, or even great work that comes out of the Federal Acquisition Service on the acquisition part, which is profoundly important here. So we've exposed all of this out through those mechanisms so that the rest of government can learn from us. We're not the best thing out there. We're not the greatest thing out there, but we are very intentional about putting what we do learn out so that people don't have to learn our tough challenges. All right, good question. Anybody else? Yes. Okay, so the question is about ATOs and what transformations. So authorizing workloads and products to run in the federal space is a challenge. There's great value in doing that authorization because it kind of raises the tide of cybersecurity across the federal computing enterprise. ATOs used to take 2 years, take a lot of money, pretty painful, and it was largely a compliance thing. And at the end, you just had a fancy document that maybe was good, maybe wasn't good. Didn't really impact the practical cybersecurity posture and stance of a system. So we started doing agile ATOs to make that more rapid. A bad thing done more rapidly is less bad because at least it shortens the pain and suffering. So we did that, and then we started doing business process reengineering on the ATO process using true agile stuff where we said we're going to use the DevSecOps model on the ATO piece so that when we're actually looking to deliver new functionality, we have the security people embedded in there, and they're basically crafting the ATO documentation and framework as they go along so that when we go to deliver something, the basic blocks of the ATO are built already. Then it's just a paperwork process to kind of push it through the machine. We found that the lift on our industry partners is much less because we're actually able to influence them just as they influence us through the delivery process. And then we're pivoting to continuous delivery of capability, where we're moving to continuous ATOs rather than a once every 2 or once every 3 year authorization, which again is a compliance activity, and the risk to a risk management-based framework where we're saying we're going to be analyzing and assessing the cybersecurity posture and stance of a thing during its entire life cycle is the best way to go. Thank you for the question. That's a really good one. All right, 14 seconds, so I think I'm out of time. Good job with this back there. I appreciate it. Thanks for the time and the conversation today. I really appreciate it.
All right.